So we're going to review acids, bases, and salts in this video. The first thing that you need to do is understand the difference between acids and bases. And I've made a little T-chart here to help you understand how to compare them. You can copy these down. It's a great super simple tool to get some notes on acids and bases. So essentially what you need to understand is that the acids and bases are on opposite ends of the pH scale. Okay, so if you're on a pH scale and you look at anything less than 7, you're going to have an acid. Acids tend to be sour, like you think of a lemon. Lemon juice is an acid. Acids react with metals to form hydrogen gas. They change the color of litmus paper. So litmus paper is an indicator, and this is the name of it, litmus. And what it does is it indicates whether or not you have an acid or a base. So litmus is an indicator. I'll write that down, indicator. And if you have a piece of blue litmus, it will turn the litmus paper red. Acids combine with bases to form salts, and they release hydrogen ions. Okay, so there it is there. The base is on the upper side of the scale, so if it's greater than 7, that's what this little symbol means. This means greater than. Okay, if it's greater than 7, then it's a base. And bases are bitter. They typically tend to be things that are slippery. They change the color of litmus paper. Don't forget that indicator is litmus paper. So if you put a piece of red litmus paper into a base, it would turn it blue. If you put blue litmus paper into a base, it would stay blue. Okay, and it increases hydroxide ions. That's for a little bit higher level understanding. For our purposes, you just need to know that we get hydroxide ions in bases, and it reacts with acids to form a salt. So if you look here, it combines with a base to form a salt, it combines with acids to form a salt. So if you have an acid plus a base, you get a salt. Okay, so you're going to see a lot of diagrams and things like that. Usually on tests, you'll have a pH scale diagram. So essentially what you have to remember is 7 is the midpoint. Okay, so I'm just going to draw a midpoint down here. And this is considered neutral, so it's not an acid or a base. So if you look down here, this is an acid, acid, acid. And as you get lower, so the lower the pH, the higher the acidity. So down here is a strong acid. Okay, and then up here, like around 7, these would be considered weak acids. But they're still acids. And similarly, when you get down to this end over here, these are strong bases, strong base, and over here would be a weak base. So the higher the pH on the base side, the stronger the base. The lower the pH on the acid side, the stronger the acid. Okay, and then if you're in the middle, it's considered neutral. Okay. Another thing that I want you guys to understand is sometimes when they present the pH scale to you, that might change the orientation of it. It still means the same thing, okay? So if you have a really low pH at 0, this is a really strong acid. Here we have 7, which is neutral, and then here we have 14, which is a really strong base. So they might present a pH scale to you differently. So just because you learned it horizontally doesn't mean that they can't present it to you vertically when they're asking you questions. Again, here's another presentation of the pH scale. They can present it in any way. So make sure you understand that you have to look at the numbers, okay? So this is a strong acid, this is a strong base, okay? And so the pH scale goes from 0 to 14, and again, 7 is neutral. And if you look here, it's water. And usually things that are sort of found in the human body are within this like range of neutral, like 6 to 8. Okay, bodily fluids and things like that are generally typically come from this part. Now, they get dangerous when they get really low here, but look at lemons are too. So it actually, if you've ever eaten lemons or eaten a lot of lemons, you might get like canker sores on your mouth. So that just goes to show you that it can be dangerous to tissue. And bases typically are cleaning products and things like that you don't want to get on your skin, or they usually have warning labels on them if they're a base. Here's another one. This one calls them acids and alkalis. And the term alkaline is just another word for a base. So if someone says something is alkali, that means it's basic. So let's put base is alkali. Okay, so we call it a base. This would typically be more in the chemistry class that you would learn alkaline. In lower level science classes, you would just consider it a base. Okay, so here's some of the things that you have to know about salts, because we need to understand both acids and bases and salts. And if you put an acid and a base together, you get a salt. Okay, so salts are formed from acids and bases. You also get a salt when you get a positive ion, which is also known as a cation, and a negative ion, which is known as an anion. If you combine a positive ion and a negative ion, you'll get a salt. And we see this, for example, in sodium, which is a positive ion, it's a cation, and chlorine, it's a negative ion or a cation. And when these two are combined, you get sodium chloride, which is, it's just table salt. That's exactly what it is. It's just salt. So the cation is held together with the anion because of the opposite charges. So this opposites attract, and so these two would combine together, and they'd be held together with an ionic bond. And a salt is also a combination of a metal and a non-metal. And if you take a look here, please don't look at my words on my periodic table. I think I got the Italian periodic table, but I just wanted to show you on the left side of the periodic table, this is where we find the metals, okay? And these are transition metals in the middle. But for our purposes, we would have to know that left side, you would find metals. And right side, you would find non-metals, okay? And the further right you get, the more non-metallic they are. So if you take a look here, here's some examples of salt. So let's look at sodium chloride, okay? And so if you go over here to the left side, you're going to look in your metals and go, oh, there's sodium right there. And this is a non-metal. And if you look here, there's chlorine. So if you combine those two together, you will get a salt. Potassium iodide. So here's potassium. That's K. Potassium symbol is a K. And iodine is right here. So this is called potassium iodide. It's a salt because it's from a metal and a non-metal. And then lithium fluoride, again, let's look over here. Here we have lithium, and here's fluorine. And if those two are combined, they form a salt. And these are all ions. So sodium, sodium is a cation, chlorine is a anion, potassium is a cation, iodine is an anion, lithium is a cation, fluorine is an anion. And when you get a little more into chemistry, you'll learn a little bit more about those kinds of things. So those are the things that you have to know about acids, bases, and salts.